that me half. No, wrong one. Bugger. That one's me. Hello. That one's me. I need that one, hopefully. Hey! So that is gone. That is up. And people you can hopefully hear me. I'm unsure. But that should be going. And that's load. And okay. Let's go. So I'm going to talk a bit, very briefly, about pi. Nothing of great interest, but maybe of great interest. But basically, geometry, it's fun, and so is pi. So pi, probably already know, mathematicians for years have been fiddling with it, and they've prided themselves on knowing it for long numbers, because it's not really easy to find, because it's transcendental, and all the stuff. So it goes on forever, and it's a pain in the ass. And recently, I was set a problem. I was told, teach a computer that the area of a unit disk is pi. And I thought about it originally. I thought, okay, this shouldn't be that bad. I can just take polygons. And I was working with a group of people in New York, and they said, no, you can't just take polygons. And first we'll look at the polygons, and then we'll look at the way we actually did it. So we can look at a square, basically, give it radius 1, and we can approximate pi pretty easily. So we can approximate it, and we get root 2 of the sides, and so we have pi is 2. A brilliant approximation, won't you agree? And we can then take it to a pentagon. So instead of having 90 degrees, here we could take it in triangles, calculate the triangles, but squares just easy to times the sides. So now we have split it into triangles with 72 degrees in the angle. And we know that the two sides here, they've got a side length of 1 because they're a radius. And then we can do half AB sine C. So we can find pi is approximately 2.377, which better. And we can do the same for hexagons. N equals 6. This one's just a hexagon. And you can see what we're doing here is we're just increasing n. And we're getting bigger and bigger. And so we get more and more sides. And it goes slowly more and more towards a circle. And then we have more and more sides. And a bit like squaring, but not exactly squaring. We're just making it more and more like a circle. So we just again, half AB sine C. So that's sine 60 plus 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 sine 60 over 2. Which is approximately 2.598. And now we can go a bit further, because I'm not going to go through any more. I'm sure you've worked it out by now. So what if we take an infinite-sided shape? We think about that for a bit, and that's a circle. And what we've done is we've taken n to infinity, just a circle, and so we've got a limit. So we take the limit of n over 2 sine 360 over n. I'm aware there's probably a few issues there, but we're going to brush over them. And that's pi. And we have the area of the circle. So what we've done is we've taken a circle and we've just reduced it into very small and very long triangles. Not rectangles. And finding the area of a triangle is easy, half AB sine C. And then we can do this infinite number of times and we have the area of a circle. But this is very hand-wavy. And when you're teaching this to a computer, you can't. So I had to come up with a better method. And I thought about it for a while, and I didn't quite know what I was doing. So they came along and said, okay, let's start with a circle in a 2D plane. We know this is x squared plus y squared, which is 1. And if we take the circle and we apply some measure theory, we can show that a circle or a unit disk is a circle here. Don't worry about the measure theory. I don't really understand it, but I trust that it is measure theory. And that then means that we can say that the area of a circle is an integral, which is that, and we can do that using fundamental theorem of calculus, and we have that the area of a circle is pi. And we're done.